countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by eDidik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Hi. Okay, Bismillahirrahmanirrahim. Okay, hello there everyone. Okay, Assalamualaikum and very good afternoon. Okay, welcome to Pusat Tuisyen Academy YouTuber, a joint venture with eDidik Malaysia and Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Okay, before we proceed, let's begin our session with the recitation of Kitab Al-Fatihah, and for the non-Muslim, please recite your prayer according to your religion. Al-Fatihah. Amin, amin, ya Rabbal Alamin. Okay, how is everyone today? Okay, my prayer that everyone is doing fine and ready to proceed with today's class. Okay, I am Cikgu Hapsah Ayu from SMK Sultan Sulaiman, your moderator for today. And together with us, with me is our control host, okay, Teacher Su, okay, from SMK Sri Serdang. Okay, our observer, Cikgu Nun, okay, Cikgu Nun. Okay, from College Matrikulasi Negeri Sembilan. And our important person of the day, our presenter, Madam Rosmaya. Okay, Madam Rosmaya. Okay, from SMJK Yuhua Kajang. Okay, for the record, we are now live on Madam Rosmaya channel. So, as a sign of support to Madam Rosmaya for her hard work in preparing today's lesson, please subscribe her channel, not forgetting ours too. Okay, as usual, the lesson will last approximately for 1 hour. And please follow the class up until the end and give your full cooperation in making this session a lively one. Okay, please take note that the certificate link will be given at the end of this session. Okay, besides this, don't forget to claim your credit for today's live class. Okay, collect the credit to redeem the attractive prize in store. The link to claim the credit and the presenter username will also be given at the end of the session. However, please be alert as the 5-digit code to claim your credit will be announced 1 digit at a time during the live class. Okay, so you get ready with your pen and paper. Okay, the digit, okay, teacher will give for the first digit combined with a letter and a digit. Okay, for the first letter and digit is A4. Okay, student, you can take note. Okay, I would also like to remind students to use approximate language and also use appropriate profile picture if possible. Okay, use your own picture. If you wish to post comment on the chat box. Okay, I'm pretty sure all the students here are excellent students who will uphold a positive classroom environment. Okay, student. Okay, stay focused. And if you have any question, please write on the chat box and Madam Rosmaya will try to provide you with the answer. Okay, so without further ado, please welcome Madam Rosmaya. Okay.
Okay. Hi everyone. I am Madam Rosmaya. Okay. So I am a physics teacher at SMJK Yuhua Kajang. Okay. So we are going to start our class now. I'm going to introduce the pre-U teams in Academy YouTuber. Okay. So our team, today all of us, all from physics, all from physics team. Okay. Our control host, okay, Sue, moderator, Ayu, and at the bottom is Cikgu Non. Okay, all is in physics team. Okay, and I am the leader, okay, from of the physics team, and one more teacher is Teacher Suhaya. Okay, next is we also have maths team led by Teacher Im. Okay, we have biology team led by Cikgu Faiza, and chemistry team led by Teacher Shahnun, and perakaunan dan ekonomi led by Madam Fizi, and besides that other STPM subjects. This one we have pengajian am, muet, pengajian perniagaan, and perakaunan. Okay. So now, what is our objective for today? So our topic today is alternating current circuits part 1. Okay, so at the end of the lesson, students should be able to explain the phase difference between the current and voltage for a pure resistor or inductor or capacitor, and also explain the concept of RMS value of an alternating current and calculate the value for the sinusoidal case only. And the third objective is to derive the formula for the power in an alternating current circuit. Okay, so today's discussion, we have a lot of explanation will be done. Okay, including the derivation. Okay. So for alternate current, okay, we are going to divide into 3 circuits. Okay, for the AC through a resistor only. This is a pure resistor, means no other opposition to current in here, only comes from resistance, okay, of the resistor here. And we are going also to discuss AC through an inductor and AC through a capacitor. Okay, so we are going to find the phase relationship between current and voltage in all this circuit, and why there are a phase difference between voltage and current. Okay, so we start with resistor. Okay, so this is a simple circuit, consists of resistor only. Okay, the supply is from the alternate current. Okay, if we put a voltmeter across the resistor, because this is alternate current, so the V is given by V naught, V peak, okay, sine omega t. Okay, so the graph is a sine graph. Okay, the graph is a sine graph. So the peak voltage can be read from here. Okay, this is the peak voltage, and omega is 2 pi f, and from the period here, we can get frequency here. T equals to 1 per f. Okay, next, we use from Ohm's law, we use V equals to IR, and I is V per R. So we can substitute this V into the equation here. So we get V peak sine omega t per R. And this V peak per R is I peak. Okay, V peak per R is I peak. So we get equation of I. Okay, I equals to I peak sine omega t. So we can see here that the equation here means that when we plot the graph, I against t is also a sine graph, right? It's also a sine graph. And we compare these two graphs, you see, they are actually in phase. Okay, I and V are in phase because they reach the peak at the same time. Okay, starting the same point here, okay, reaching the peak also same points. In another word, we can say phase difference equals to 0. Okay, so if we combine both graphs together, we can see clearly where they reach at time here. This is time. So a certain time, they reach the peak at the same time. That's why we say that I and V are in phase. Okay. Okay, that's the reason why for resistor, I and V are in the same phase. Okay, next we have done for the AC through resistor. Next we discuss AC through inductor. Okay, AC through inductor. So AC is alternate current through inductor. Okay, So this is the simple circuit, okay, consists of only pure inductor, okay, pure inductor. Okay, if you put a voltmeter across the inductor, so again, the reading of V, we use V peak sine omega t. Okay, V peak sine omega t, and the graph is a sine graph, okay, because we start with the V here. So all for resistor, inductor, and also capacitor in the AC circuit, simple circuit here, all we use initial V as V peak sine omega t. Okay, this is the starting. So what the graph of I against T will look like? Okay, for inductor, we use this equation. Okay, we discussed this already in the previous discussion, where the V supplied is the V here. Okay, the V here is equals to the back EMF negative, because the back EMF is in opposite direction. So the V across the inductor here is equals to the back EMF. Okay, now we substitute this V into here. Okay, so, and also from the equation of back EMF, negative L di by dt. L is the inductance for this inductor. So we substitute negative L di by dt. So negative become positive. And we arrange the equation here. Di by dt equals to V peak sine omega t per L. Okay, so we rearrange this equation. So we get this. Okay, now because we have two variable here, I and dt, so we use integration. So we separate the variables, I one side, to t one side. Okay, so V naught sine omega t per L, okay, remain here. Then we can integrate both sides. So we take the integral both sides and we solve using integration rule. And V peak and L is a constant, so we can take out here. And nothing here means 1. So use integration rule. So right side, left side, this is left side. So left side we have I, and right side, V peak per L is a constant. So bracket here, when we integrate sine omega t with respect to t, so we get negative cos omega t per omega. Okay, this one you've learned in maths already, how to use the integration rule. Okay, so now we combine all the constant. Okay, so become negative V peak per omega L. Okay, this is a constant. Okay, this is I equals to negative V peak per omega L cos omega t. And this terms, negative V peak per omega L is equals to I peak. Okay, we replace this by I peak. We are going to use this later in the next discussion, not electromagnetic, alternate current circuit part 2, next week. Okay, we discuss this one. But right now, we concentrate on I. So what the graph of I against T looks like here? Okay, I equals to negative I peak cos omega T. So it's a cosine graph. Okay, it's a cosine graph with negative, negative. So opposite of cosine graph, the normal cosine graph. Okay, so to compare the phase, we change, we convert this cos omega t into sine omega t minus pi per 2, okay, to compare the two I and V. Okay, so the phase is given by pi per 2, okay, pi per 2. Okay, if you're not sure about this relationship between cos and sine, you can try to substitute any values here. Let's say omega t is 20 degrees, so pi per 2 is 90 degrees, right? So you try to substitute, you will get they are actually the same. Okay, the same value. You can use calculator, but we just use the relationship here direct from the maths you've learned before. So if not, you are not sure, you can substitute with values to confirm yourself. Okay, how the relationship between cos and sine. Okay, so now the graph looks like a cosine graph. Okay, just look at this I erase all the steps just now. So for I against T is a cosine graph, and negative, so it's upside down. I start with negative here because negative, I not cosine omega t. Okay, now compare these two graphs. What can be seen? Actually, I and V are not in phase, right? They are not in phase. So for how many? For how many phase angle? Okay, so the phase angle is by this, compare this sign. So the phase angle is pi per 2. Okay, pi per 2. Compare this part, the phase angle, the phase here, omega t, whereas for I, the phase is omega t minus pi per 2. So you minus these two, you get phase difference pi per 2. Okay, where, okay, which one is leading? V, V leading I, because V here, okay, and then followed by I, okay, from the graph. You can see clearly if you plot on the same graph. You can see if you plot this I and V against T on the same graph, you can see clearly that V reach peak first. So they do not peak at the same time. So P voltage peak first, and then current. Okay, voltage go to peak first, then current. So that's why V leading I. Okay. Okay, so now we've done for inductor. Okay, so for inductor, V leads I by how many? Pi per 2 radians. Okay. Okay, so if you got any question, you can ask there in the chat box. I try to answer your question. Okay, next we continue with AC through capacitor. Okay, what we get for AC to the capacitor, what is the phase relationship between current and voltage? Okay, we start with the simple capacitor here. Okay, a simple circuit here consists of capacitor only, pure capacitor. Okay, power supply is the alternate current, and the voltage across here, we use V equals to V naught sine omega t, the initial peak. Okay, V peak sine omega t, the initial voltage, potential difference. So the graph is a sine graph. Okay, now to calculate I for capacitor, we use I equals to dq by dt. I equals to dq by dt because from the capacitor here, capacitance and the V here, Q is equals to CV. Okay, Q is equals to CV. And we can substitute V equals to V peak sine omega t into the equation. Okay, so we get, okay, C is constant. C is constant. We can take out, bring to the front, and the V we substitute with this V peak sine omega t. Okay, now we use differentiation rule. Differentiation rule. So V peak also a constant. We take out in front. So CV naught, CV peak, CV peak d sine omega t per dt. So this sine omega sine omega t by dt we give you cos. So omega cos omega t. Okay, use differentiation rule. Okay, you've learned in maths, right? Use differentiation rule. So you get omega cos omega t. Okay, so now we can write as I equals to I peak cos omega t. So this constant value, C omega peak, C V peak omega, okay, this one is equals to I peak. Okay, so we are going to use this letter again. I repeat, we are going to use this terms later in the next discussion, next week discussion. So for right now, we just concentrate on V and I. So the I can be written as I peak cos omega t. Okay, so again, it's a cosine graph. Okay, so for I against t, if we plot the graph, it's a cosine graph. But this time, to get the how many their phase difference is, so we convert cos omega t equals to sine omega t plus pi per 2. Okay, so we convert this, use the identity of cos and sine. So cos omega t is equals to sine omega t plus pi per 2. So if you're still not sure, you can substitute any values here and you will get that they are the same answer. Okay, just substitute any values. 20 degrees, 30 degrees or whatever, plus pi per 2 for sine, you will get equals to cos that degrees you chose just now. Okay, now back to the graph. So just for graph I against t. So it's a cosine graph and it's a positive. So the shape here is start from positive here. So this is a cosine graph. And again, we can see compare I and V, they are not in phase. Like resistor just now, right? They are in phase. But for capacitor, they are not in phase. Okay. So can see here is that it doesn't start at the time 0 here, so it doesn't start at the same time. Or another word, when they reach the peak, they are not reached at the same time. The peak reached by them not at the same time. So the phase difference is pi per 2 because to compare the sign, you must convert must have the same form, right? So the V is in the sign form, I also must in the sign form, so that the phase here can minus, so you get pi per 2, right? The phase difference is pi per 2. Okay. Okay, this means that I leading V. Okay, I leading V. So how you can see, okay, it's better if you combine these two in the same graph. You can see which one reach peak first. So current peak first, then voltage. Okay, so that's why I leading V. Okay, current lead V. That's how you see to see the relationship between current and voltage. Okay, so current and voltage do not peak at the same time. So if you combine the graph together, you see that current peak first, then voltage, followed by voltage. Okay, so we've done for all. So this is the conclusion we get. So for AC to resistor, I and V are in phase. For AC to inductor, so V leads I by pi per 2 radians, and for AC to a capacitor, I leads V by pi per 2 radian. So you see this, for inductor and capacitor, they are opposite of each other. Okay, and if you refer to some books, they use lag, instead of lead. But if for memorizing, better you choose one only. If not, you get confused because the English word here is similar, right? Leads, lag. So you just stick to one. Leads. So better stick to one. Can also, if you want to memorize like this. Okay, I lags V by pi per 2 radian, or in capacitor, V lags I by pi per 2 radian. Okay. So to memorize it quickly, actually, you can use the word civil. Okay. For capacitor, I lead V. Okay. For L represent inductor. For inductor, V lead I. Okay. This is how to quickly memorize. Okay. Or if those who are have imagination, the what you call that, by picture lah, by diagram, you can also memorize as, because capacitor usually we use this sign, right, this symbol, for capacitor. So this is in the similar shape to I. So for capacitor, I leads V. Okay. For inductor, usually we use this symbol. Looks like E. E stand for EMF, right? So that means V leads I. So it's up to you how you to memorize the phase in between relationship between I and V. Okay, the best you want to memorize it. So it's up to you. Okay, so
Madam,
yeah.
can we share the third or we call 2, the second digit?
The second digit.
Second digit. Okay, the second digit is number 3. Number 3. Okay. Okay, can.
Okay, so thank you, Cikgu Ayu. Okay, so we continue. Okay. Okay, next we are going to discuss the RMS value. What is meant by RMS value? Because we are going to use this to derive the power later. So you need to know the RMS value and relate also it with the what you call that, the relationship between I and V. Okay. Okay, so what is RMS value? Okay, RMS value of an alternate current. Wait, my battery is weak now. I'm going to put it. Fahim, tolong battery. Okay, sorry, because my battery here weak. I forgot to connect to the power supply. Okay, so we continue. Okay, sorry for that. Okay, what is meant by RMS values? So the RMS value of an alternate current is the value of the direct current that dissipates heat at the same rate as the mean power dissipated when the AC flows in the resistor. Okay, so what does this mean? What does the statement means? Okay, refer to the diagram here. Okay, refer to diagram here. We have two circuit. The first one is the bulb with the I current from the direct current, okay, from the direct current. The second is the circuit from AC current, okay. So the bulb we use here is identical light bulb. Okay, so to compare how the heat dissipates, okay, so we can see from the brightness, okay, from the brightness instead of using the resistance, okay, so we use the brightness to compare. Okay, so that's mean if their brightness is the same, so that's mean they dissipate heat at the same rate. Okay, they dissipate it at the same rate. So that's mean they are losing the same amount of heat regardless the fact of AC or DC. So that's mean this I direct current here is equals to the I RMS for the AC current circuit here. Okay. So in order to relate both, we have nothing to use better than the RMS value. Okay, so now we continue. So why we use RMS value instead of average values? Okay, refer to the direct current just now. Okay, we know that I and V is a steady current, right? A steady current. The V also, they are at the same, means constant all the time. Okay, constant all the time. This is for direct current. The value is always constant. But from what we've discussed in the previous slide, okay, we get for not for capacitor, for resistor, the source comes from the AC current. The graph we get is a sine graph. So they are not constant all the time. Okay, the values are always changing. And attempts to find an average value of AC would directly provide you the answer 0. Let's say you total all the positive part here, and then plus the bottom here is negative value, right? You will get 0. Positive 2 minus 2, 0. Let's say negative 3 and negative 1 plus, positive 1 plus negative 1, 0. So the total, the average value all, you will get answer 0. Okay, so it's not possible to use the average value. Okay, so hence we use RMS value instead. Okay, for the next calculation for power, we are going to use the RMS value. Okay, so we what does RMS means? In mathematics, okay, RMS mean it equals to RMS equals to square root of x1 squared plus x2 squared plus x3 squared plus plus xn squared divided by n numbers of the x. Okay, so first we square all the values and then we find the average, okay, for the complete cycle. Then we find the square root. So this is the formula for XRMS, okay, for mathematics. So that's this means of x squared. Okay, this one is mean of x squared. So in the mathematics symbol, we can write like this. Okay, now we are going to relate this x with current. Okay, with current, because we are going to determine power. Okay, we are going to determine power. So we discuss on this circuit first. Okay, this circuit first. Okay, for this circuit, the current, the circuit here consists of R. Okay, R from the AC supply. Okay, the instantaneous power dissipated from the resistor, okay, is given by P equals to IV. Okay, so the V equals to IR. So substitute into the equation. So we get instantaneous power equals to I squared R. Okay, so better we use this one. Power dissipated from the resistor, I squared R. Okay, so now we want to find mean power. Okay, mean power of the resistor here. So the mean power is equals to mean value of this I squared R. Okay, R is constant, so we can take out. Okay, bracket is the mean value of I squared. Okay, mean value of I squared. So next, the mean value of I squared. Okay, in the previous, this one is mean of x squared, right? So we are going to use this equation. Okay, x replaced by I. So that's mean value of I squared is equals to I RMS squared. Okay, from this now. Okay, square root both sides. So actually mean value of I squared is I RMS squared. Okay, from here actually. Square root both sides. So you get I RMS squared equals to mean value of I squared. Okay, so now we can write as mean power equals to I RMS squared R. Okay, so this is one equation for the mean power. Okay, we are going to derive next mean power, and I think we can take a rest before we go to the next mean power. Okay, to derive the next mean power.
We take a break.
Berita baik untuk semua. Kini, Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, we are back.
Okay, so we continue. Okay, we continue with the mean power for the other formula. We still use the same circuit. Okay, we still use the same circuit, which consists of pure resistor. Okay, supplied by the alternate current. Okay, we keep this for a while because we are going to compare the next derivation of the mean power. Okay, instead of using the IRMS, the second step, we can use I peak sine omega t. Okay, this one is for the supply for the alternate current circuit here. So we use I equals to I peak sine omega t. Because here we use IRMS. So here we use I peak sine omega t instead. So we substitute I peak sine omega t bracket squared times R. Okay, and we expand the bracket. Okay, become mean value I peak squared sine squared omega t. Okay, and then we put R combine. Okay, this is nicer to look at, right? The equation. So we get mean value I peak squared R sine squared omega t. Okay, next. I peak is a constant, R also a constant, so we can take out, bring from to the front. So bracket leave only mean value of sine squared omega t. Okay, this is what the change comes from, right? This 2 is a constant. So the mean value of sine squared omega t. Okay, now we are going to use the trigonometric identity here. So we use sine squared theta equals to half bracket 1 minus cos 2 theta. Okay. So from cos theta equals to 1 minus 2 sine squared theta. So we bring sine squared theta to the front. So we get this. So we are going to use this. So we substitute into here. We get half bracket 1 minus cos 2 omega t. Okay. We just use maths, trigonometric identities. Okay, this one you've learned and proved already in your maths T, right? Okay, now cos omega is 2 pi f. Okay, so cos 2 omega means omega 2 pi f. So again, we use maths here, where this one is equals to cos 4 pi ft, and the value is actually 0. Okay, so the mean value for cos 4 pi ft equals to 0. So we just use maths here. All this comes from maths. So it's equals to 0. Okay, so now leaving only half, I peak squared R. So the half, mean value of half times 1 here is half. And this half also a constant. So that means the mean value of half is half. So combine all this, we get mean power equals to half I peak squared R. Okay, so this is the another equation for the mean power of the resistance in the AC circuit. Okay. Okay, now actually both is the same. Actually, both is the same, right? Okay, as we discussed just now, for the RMS squared R, where the I is RMS, so the mean power will be the same. Okay, because current here it will be the same. So we compare here, equate them both. Okay, equate them both. Then we can cancel R. Okay, cancel out R. So we rearrange the equation. We get square root both sides. So we get I peak per cert 2 equals to IRMS. So this is the formula. We derive the formula or the relationship between IRMS and I peak. So memorize this formula. Okay, memorize this formula. IRMS equals to I peak per cert 2. Okay, so the relationship between RMS and peak values. Okay, next we are going to derive the relationship between VRMS and Vpeak. Okay, VRMS and Vpeak. Okay, this one for current. Next is the for voltage, or potential difference. Okay, so IRMS, we use equation V equals to IR. Okay, for the circuit with the resistor just now from AC, okay, if you use V peak, the I and the pair must both in peak. If V peak, you use I peak. You cannot mix V peak and IRMS. So if you want to use V equals to IR equation, so for V peak equals to I peak R. Okay, so we get I peak equals to V peak per R. So if you want to use VRMS in the equation, in this equation, for the alternate current circuit consists of R, so you use VRMS equals to IRMS R. Okay, you cannot mix them. So therefore IRMS you get equals to VRMS per R. Okay, so now you can substitute into the above equation here. Okay, RMS and I peak. So you substitute this one into I peak and IRMS into here. So we get this. Okay, next we can cancel out R. Okay, cancel out R. And what is the equation for VRMS? We get V peak per cert 2. So it's similar, in a similar form, right? IRMS equals to I peak per cert 2. VRMS equals to V peak per cert 2. Okay. So done for the relationship between RMS and peak value. Okay. Okay, so the second part of our discussion here done. Okay, next we try one example here. Example to relate these two, how to use these two. For example, here you are given the current as 8 sine 20 pi t. I is in ampere. So find the peak values of the AC. Okay, find the peak value of AC and find the RMS value of the AC and find the frequency of the AC. Okay, so can you try now? Okay, can you all try now?
Okay, madam, can we share the third?
Okay, while they're trying.
Okay. Third digit is number 3. Okay, number 3. Okay.
Okay, student, can try now. So what is the peak value of the AC? You are given the current equation, 8 sine 20 pi t. Okay, so try to answer. You can write there in the checkbox. And then use the above equation that we have derived here. Okay, what you get? Write there in the checkbox as a sign that you are there with me. Okay, just now I'm done the talking until now. Looks like I'm alone here. So please with me, show that you are with me. Okay, with all the teachers here. There, I can see. Okay, from Gao Min Chai. So that's mean I'm not alone here. So Gao Min Chai, you get peak value 8 ampere, RMS value 5.6 ampere, and the frequency 10.0 hertz. So actually, it's very easy equation to try, right? Yeah. The rest of you who've tried, okay, can
Okay.
there.
Young
Okay, so many of
also
you. Young,
get the answer and Balamati.
Okay, thank you. You are with to show that. I know that you are still with me. Okay, we check. For those maybe you who still cannot get the idea. So let's do this example. So from the I equation, I equals to 8 sine 20 omega t. So we compare this with the general equation, I equals to I peak sine 2 pi ft. Omega is 2 pi ft. So you compare this. So the peak value is given by I peak equals to 8. So we can get directly from the equation. Okay, very easy actually. So the peak value is 8 ampere. So you cannot write it in the three significant figures, okay? Because given here is 8, right? Given here 8. So you must write in one significant figure only. So be careful. So one significant figure only because given here 8. Okay, next. For the RMS value, you can use this relationship. So for RMS equals to I peak per cert 2. So you substitute this 8 into the equation above. Okay, so you get 5 point. Okay, your answer correct. So 5.7 ampere. Okay, you can write 6 ampere also. 6 ampere. 5.7 round off to 6 ampere. And the RMS value, this one, done already. And the third one, the frequency. Okay, again, compare the two equation with the omega t, where omega is 2 pi f. Okay, 20 pi equals to 2 pi. Cancel the f, 2 pi f. So cancel the pi. And therefore, the frequency is 10 hertz. Okay, very good. Well done, students. Okay, so next, if you are given a graph, let's try this one. If you are given a graph, so find the RMS value of the AC voltage and the frequency of the AC voltage from the graph given. Okay, let's try, student. Can write there in the chat box after you've done. Okay, what values can we get from the graph? This is the V against T graph. Okay, I'm waiting here. Okay, no answer yet, They are still trying. Okay, what can be read from the graph? The values given here. Okay.
Okay, Young. Young
Okay.
answer 1.41.
Okay, so 1.41 volts for A, and for B, the frequency is 100 hertz. Okay, so let's check the answer. Okay, what can be read from the graph is the peak, the peak here. 2 volts here is means the peak value. So we can use the relationship VRMS, the V asked by the question. V peak per cert 2. So we substitute the V peak 2 per cert 2. So we get 1.4, 1.4 volts. So you round it off you round it off according to the significant figures. The lowest significant figures here, voltage is 2 significant figures. So you round it off to 1.4. Okay. Don't write like me. I put here 4 significant figures. So if you write like this, you won't get marked for the answer. So you round it off according to the data or information given in the questions. Okay, next for the frequency, we can read from the graph for the time axis here. So one complete wave, this is one complete wave or one complete cycle given 10 millisecond. Okay, so period is 10 millisecond. So that's what we can read from the graph. So the relationship between T and frequency is 1 per F. So 1 per 0.01, we get frequency 100 Hz. Okay, so correct, Yong? So very easy actually. This topic, you can score actually this topic if this question come out. Okay, so we just two questions enough. Okay, two questions enough. We go for power in the AC circuit. Okay, power in AC circuit, we try for the same circuit, consists of resistor first, okay. So in direct current circuit, okay, the voltage and current are generally constant, okay. So we can find the P using formula P equals to IV directly from here, okay, for direct current circuit. But for the AC circuit consists of resistor. Okay, this is the V against time and I against time. They are in the same phase, right? So the I and V keep on changing, right? In the AC circuit. So the instantaneous value of voltage and current always changing. So therefore, power also constantly changing, always changing also. Okay, influenced by the supply. Okay, so we cannot use the formula P equals to IV, okay, to find the same manner as we use in the DC circuit. So how are we going to measure the power in the resistor in the AC circuit? So how are we going to measure? So we are going to derive the equation for the power in AC circuit consists of resistor. Okay, one by one. So we calculate for R first. Okay, instantaneous power for P, okay, given by P equals to I squared R. Okay, so the I is, we use I equals to I peak sine omega T. Okay, I equals to I peak sine omega T. So we substitute into here, and omega is 2 pi F. So we get this value, P equals to I peak sine 2 pi F T squared. Okay, so we expand the bracket. So become I peak squared R sine squared 2 pi ft. Then we bring R to the front, so we get this. Okay, so now, what is the graph will looks like? What is the graph will looks like? So this one is sine squared, right? So if sine squared, if we get positive value, we get positive also, and if this negative, also we get positive. So the graph all is positive. Because the negative value given, always when you multiply together, you squared, it always positive. So the graph is always positive for power against time. Okay, you've learned in maths, right, how to sketch the graph of sine squared. Sine squared, we get this graph. So imagine the one cycle, you get a one positive, one negative for sine, but this is sine squared, so you get all positive. Okay, so the peak value, okay, is given by this one, I peak squared R. So this is the peak value. Okay, so now compare with the current, that we discussed before, this one, the current and the voltage, here. So we combine the graph. So what happened? So this is the sine graph and the voltage graph, because this is for resistor, right? So they pick together, same, in other words, I and V are at the same phase, same phase. So the power also, the same, because positive times, this is sine squared, right? So positive times sine positive will give you positive value. Okay, this is the graph. Okay, you see, for the first cycle, so positive times positive is positive. So during the positive half cycle here, you see, so I and V are positive. So the power is positive. Okay. And for the another half cycle here, you see negative, right? So I and V are negative. So what is the result? So resulting the power being positive also. Okay, because negative times negative, right? Generally I times V. So negative times negative will give you also positive. So that's how we get the power against time graph for across the means power in the resistor here. Okay. Okay, so now area under the graph for the positive side here, okay. For electrical power, this means that electrical power in the resistor here is consumed all the time, okay, because it's on the positive side. Okay, electrical power is consumed all the time. It shows the energy, the energy consumed by the resistor here. Okay, so and from the previous discussion also, the mean power from here, right? From here we discussed the mean power is given by half I peak squared R, right? Okay, half I peak squared R. So therefore, it divide into half here. Peak is I peak squared R. This is the peak. So the mean power is given by the in between here. Okay. So half I peak squared R is the mean power. From the graph, we can get the value here. And also remember, it's also equals to Rms squared R. So if you are given the graph, like just now, you can calculate both actually. You can even get IRMS, not just I peak. Okay, so resistance is constant. Okay, now for the AC circuit, okay, we've done. Okay, so for the AC through a capacitor, I've made a video actually. I've made a video for the AC because I prepared the slide only until here and I make a video. I'm afraid we don't have enough time, but actually we still got a few, but it's okay because I make a special video for you all for this AC through a capacitor. Power for AC through a capacitor and AC through an inductor. You can refer to the video for these two. How we are going to derive these two power for across power for the capacitor and power across the inductor. Okay, so where we do the same method. Actually, the method we use is the same from P equals to IV, but this time the I and V, you know already, right? They are not in the same phase. So you substitute I peak cos omega t and V peak sin omega t into P equals to IV, and you derive, you get this one. Use all the trigonometric identity in the formula in the maths. Use that one. So you get sin omega t. Actually, half sin 2 omega t. Okay, so sin omega t, cos omega t, you use trigonometric identity, becomes half sin omega sin 2 omega t. So you get the instantaneous power for the capacitor as a sine graph. And sin omega t, so that means it's double. Okay, it's double. Okay, because 2 omega t here. So that means for one period, for the period here, so the graph, the cycle here becomes double. Or in other words, the frequency is double. You see, the frequency is double. So this is the shape of the graph for capacitor. So for inductor will be opposite, because for capacitor, I lead V. So for inductor, V lead I, right? If V lead I, so to compare with the power in capacitor, so it will be opposite direction. Okay, like this. So we have also negative part and also positive part. So the positive part means that the energy is consumed, by the capacitor. For inductor also the same. But for the negative part, so that means the energy is returned to the back to the power supply. Okay, for the negative part, because it's alternate current. It keep on changing direction. So the power is returned, the energy is returned, and the energy is consumed. Remember, for capacitor inductor, the energy is keep on this AC current, right? So it keep on changing direction. So that means the energy can be consumed and or returned back. Actually stored, not consumed. Energy is stored in the capacitor. okay, or also in the inductor. So I use the wrong word just now. I use consume. Actually, energy is stored for capacitor and inductor. Energy is stored in the capacitor, and at another for negative part here shows the energy is returned to the power supply. Okay, so you can refer to my video, okay, on this two derivation of the power in the capacitor and inductor. Okay, so that's all for me. I give back this back to Cikgu Ayu.
Okay, Alhamdulillah. Okay, we have reached the end of today's session. Oh, sorry. Okay, thank you, Madam Rosmaya, for preparing today's lesson, and congratulations to those who are able to follow our live class from the beginning till the end. Okay, again, student, let's thank Madam Rosmaya by clicking the subscribe button and activate the icon bell so that you will not miss the next live class, and also don't forget to hit the like button. Okay, once you have done that, please type done on the chat box. Okay, sorry. Okay, sorry. Okay. For the certificate link and the link to claim the credit are ready in the chat box. Okay, the certificate and credit link are given as a token of thank you for your dedication in joining the free online class today, and please share today's live class to your friend on your social media. Okay, spread and share the goodness. Okay, please take note, the credit link will end 15 minutes while the certificate link will end half an hour after this live. Okay, make sure to use the e-didik email only to log in. Incorrect email use will not be entertained. If you wish to get more information on the online class, okay, go to www.academyyoutuber.com. And to those who haven't joined e-didik Junior Telegram, please do so. Okay.
The last code done already? Given already?
Oh, no. Okay, the last code, okay, is number 9. Okay, number 9. Okay, so you can claim the credit. Okay. Okay. So I would like to thank all of the wonderful students, okay, for joining today. Okay, thank you for being an IU supporter. Okay, you are awesome. Okay, feel free to share this free tuition class to your friends and teachers all over Malaysia. Okay, this is a collective effort from all the teachers throughout Malaysia for all the students throughout the country. Okay, so don't forget to join our live class next week. Okay, Saturday at 5. Oh no. Sunday. Sunday at 5 p.m. Okay, till we meet again, ingat hashtag bermula percuma, berseramanya percuma. Okay, stay safe and be safe, student. Okay, Assalamualaikum and bye-bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.